Hey guys, and welcome to the rational root theorem. So what the rational root theorem is this is a tool to basically find zeros of a polynomial if we're stranded on a desert island and we don't have a graphing calculator. So the rational root theorem is a tool if for some reason you don't have access to technology. So how did we do it before we had all this nice technology and we carried around basically graphing calculators in our pockets all the time? Well, we had to go through this process. But first, so some stuff about zeros. So rational root theorem is just a tool for us to help us find zeros of a polynomial. As a review, a number is a zero if when it's plugged into the polynomial, and I mean like for x or y or z or whatever the variable is, the polynomial evaluates to zero. It zeroes out. It equals zero. That means the number you plugged in is a zero. On a graph, these zeros can be seen as x-intercepts. That's why I say this tool is only useful if you don't have access to a graphing calculator, because if you have a graphing calculator, you could graph it, see where the x-intercept is, and then get your zeros that way, at least your real zeros. So how zeros, intercepts, and factors are all related. If we know a zero, so if I knew that x equals 2 is a zero, then 2 comma 0 is its intercept, and x minus 2 is going to be its factor. So you can see that if I had any one of these, I could build the other two. So these things are all related. So just some background stuff on zeros before we start. Why we need rational root theorem? Well, this is why. Because this is the strategy to find all real zeros of a polynomial. And as a note, by hand, it's actually not possible unless the polynomial has integer coefficients and has at least one rational zero. So let's just suppose that this is the case. Okay, so if that is the case, we could use Descartes' rule to find a bound on the number of positive and negative zeros. So in the last video we saw, we used Descartes' rule and we could see, oh, we had 4, 2, or 0 positive zeros, or we had 5, 3, or 1 negative zeros. So this gives us some idea of what we're looking for. And then our second strategy is find the first zero using factoring if our polynomial factors, or rational root theorem. So rational root theorem comes in handy right there. And then once we get our first zero, rational root theorem is a tool to help us find our first zero, supposing we have a rational zero. Then we would use synthetic division to either find the remaining zeros or find the remaining factors. And then we can just kind of repeat the process until we have all of the zeros. Again, supposing though that we have rational zeros in the first place. So, in general, we would use our graphing calculator or graphing software, but for the sake of argument, let's pretend we lost everything, and even though we've lost everything, power, electricity, all technology, we still want to find zeros of polynomials. How would we do that? Well, rational root theorem is how. So, this is, move my pen out of the way, move it up here. So, what is rational root theorem? Well, it's a possible zero of a polynomial could be one of the possible combinations of the factors of the constant term over the factors of the leading coefficient, and all possible combinations of that. So, for example, and again, this is the tool to get us our first zero. Once we get our first zero, we're going to take off with synthetic division and try to find the remaining zeros. So this is the tool that we're going to use to figure out the first one. Once we have the first one, we can kind of build off of that. So here's our example. So example, what is a possible zero of 3x to the third minus 6x squared minus x plus 2 could be, so all factors of 2, so all factors of our constant term, all possible factors, and this could be negative or positive, divided by all factors of 3. So the constant term is that term, leading coefficient, remember, is that term. There's that number. So all factors of 2, we could do 1 and 2, or we could do negative 1 and negative 2. So that's all of our factors of 2. All of our factors of 3 are 1 and 3, and negative 1 and negative 3. So we have to combine all of these with all possible combinations. So we could get positive 1 over 1. We could get positive 1 over negative 1. So that's why we could get positive 1 or negative 1. We could get 2 over 1 or 2 over negative 1. So that's positive or negative 2. We could get 1 over 3 or 1 over negative 3, so positive or negative 1/3. And we could get negative 2 over 3 or negative 2 over negative 3, which is why we also get positive or negative 2/3. Okay, so that's 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 possible roots. In order to find out which one is a 0, we have to test them all. In other words, all of these 8 roots, we're going to have to plug into here and see which one of them creates a 0. And yes, it is as much work as you think it is. This is not fun. This is going to be a very long process. So in the next video, we will actually see rational root theorem in action and how we use this particular tool to find the zeros of a polynomial. And again, this is all because we're trying to do it by hand. In reality, we would use crapping software for this. But again, let's suppose we're on a desert island. Okay, so that was rational root theorem. In the next video, we'll see how to use rational root theorem in an actual example.